what is the correct Ka order of the following compounds? Means indirectly they are asking about the acidic strength of the following compounds. Okay, acidic strength, how we will see. Before starting this, I will give you a small example. After this, you will easily be able to understand this question. So what are acids? Acids are proton donors. For example, HCl, you are saying it is an acid. It is giving H plus ion and the chloride ion. So it is giving easily H plus ion. That means it is a strong acid. So H plus ion donors are the acids. In an organic chemistry, the strength of acid depends on the ion which is formed after the donation of H ion. For example, if any acid is there, for example, like phenol, let's consider a phenol. It is a very weak acid, though we can take it here. In phenol, if this H ion is lost, then we will say that this phenol is showing the acidic strength here because it can lose H plus ion here. But after the donation of H plus ion, this phenol is forming this ion here. And this ion is known as phenoxide ion. And what I am saying is, if this phenoxide ion is stable, then phenol will be a good acid. We will move on to question, but first you should understand this concept. I am saying if this phenoxide ion is stable, if by anyhow it is stable, then this phenol will be a good acid. Just for understanding. We can see here this phenoxide ion, the negative charge on oxygen will take part in resonance in this ring. Due to this, there will be stabilization in this ring, due to which this ion will be stable. And if this ion is stable, it will be formed more as well as readily by this phenol. And for this ion to be formed easily, the phenol has to lose H plus ions easily. Thus, if the ion is stable, then the acid is good. This is the concept which we will see in this question. They are asking the increasing order of K, means they are asking the acidic strength order. So indirectly we have to see the stability of ions which are formed after the donation of H plus ion. So after the donation of H plus ions, most probably in all, the negative ions will be formed. So let's see the stability of the negative ions formed after the H plus donation. The ion which will be most stable, that compound, the corresponding compound connected to it will be the most acidic, or will be having the high Ka values or high dissociation constant for acid values. Okay, so let's see, after discussing this concept, let's move on to the examples. So phenol is a very weak acid that was just taken to explain you. Which is the correct Ka order of the following compounds? First is COH. See, this is a benzoic acid. Name is not important. What it will do, see, benzene ring connected to COH, it will lose this H plus ion, and what will be formed? COO minus will be formed. Okay, if we are opening this COO minus, then how it will look like? I have to open it to show you that how resonance will be possible. So in this, there is conjugation again, and the resonance is possible. Okay, this will move here. After this, what will happen? CO minus will be formed, and it will have a positive charge. Okay, so this bond will move towards it, and the resonance will start. The negative charge will come here, it will have a positive charge. Okay, and the conjugation will continue. The resonance will continue in this compound. So what is happening here? The CO minus intermediate is stabilized by the resonance, and after donation of H plus ion, this anion is stabilized, means we can say that it is a good acid. It will have a good Ka value. But let's compare to other compounds. In other compound, we can see in the second example, it is CO minus again will be formed, and methyl group is present at the para position. It will have a plus I effect on the ring, due to which the electron density will increase on O minus, and which is not favorable for us, which is not favorable for acidic strength as well. Because if the negative charge magnitude will increase, then it will not be stable. It will be less stable as compared to the first one, in which there is no plus I group. In the third option, we can see nitro group. Nitro group is a good electron deactivating group. So in the third example, if CO minus will be formed, then what will happen? It will experience an electron withdrawing tendency from NO2, due to which this charge will slightly decrease. Okay, and it will also, NO2 also exhibit minus M and minus I effect both as well. So the minus I will be, so this electron withdrawing tendency leads to the decrement in charge, and due to this, this compound will be this ion will be maximum stable, and this will be this compound will have the highest Ka value, or it will be highly acidic up till now. The fourth compound is simple phenol. It is slightly more acidic as compared to aliphatic phenols, because when it will lose the H ion, negative ion will be formed, O minus. It will be stabilized by resonance, but it is a very weak acid as compared to the other acids. Okay, so what will happen? What will be the acidic strength? The maximum acidic strength will be of C, then A, then B, and then D. So the correct option will be third one. Okay. C. Why C? Because it is having a nitro group, which is electron withdrawing group. It will withdraw the electrons from CO minus, thus decreasing its charge. If the charge is less, then the stability is more. If the stability of the intermediate ion is more, then the acid is strong. Then comes the first option. After losing H ion, it will be CO negative. It will be stabilized by the resonance. Then the third option, it will be having the plus I effect of CH3, due to which the charge will be more. If the charge is more, the stability is less. Okay, and the least acidic will be the phenol, which is only stabilized by resonance. Okay.